Okay, hello and welcome to Module 3, Lesson 11. Another day of talking about similar triangles and some more things that go along with it. You will need the notes from yesterday in order to complete this and completely understand that, and those are yellow. They are uploaded above this video. So, in the diagram below, it says that we have triangle ABC and triangle AB prime C prime. So we have two triangles. We have the larger triangle here, and then we have a littler triangle that's sitting on top of it. And what we want to know, it says, based on the information given, is triangle ABC similar to triangle AB prime C prime? Explain. Okay, so yesterday we learned that if you have two triangles that are laying on each other, then technically you have one congruent angle already because it's the same angle. But that's actually not enough information to say that these two are similar. Remember, we have three criteria that we can use. If we have two angles that are the same, we can say they're similar. If we have three sides that are in proportion, we can say they're similar. Or if we have a side, an angle, two sides in proportion, and one angle that is congruent, it's in proportion. And none of these do we have in this case. So at this point, there is not enough info. Okay, now that brings us to what we have next. And so here's the difference. It says assume line BC is parallel. This is important to line B prime C prime. So this guy is parallel to this. If you are given that information, that changes the whole ballgame because now we have some corresponding angles. If those two are parallel, in earlier lessons, we learned that with parallel lines and a transversal, you get these corresponding angles here. So these two are parallel, and this would be your transversal. That means that this guy right here has to be congruent to this guy because they are corresponding angles. So now it says, are these similar? And now we have one angle, angle A, and also angle B that are congruent. So we can use AA. So we're going to say, yes, these are similar because of the angle-angle triangle congruence theorem that we learned about yesterday. Okay, so now that you've established that these two are similar, you can start determining missing side links. So we have side BC, and we have side AC, and we've got side AB prime, and we've got side C prime B prime here. But we do not have side AC prime. So this is saying AC, this longer length right here, is 6. And this question is saying, okay, then what is this? What is this little amount here, A to C prime? And this is how you do it. We have a match already. We have CB and C prime B prime here as a corresponding sides. And we can figure out the scale factor then by taking 8 and dividing that by 2, and our scale factor now is 4. And since we know that then, we know the larger side here is 6, and we're trying to figure this out. So since we have the large side and we're trying to shrink it down, we will divide that. So we're going to say, okay, 6 then divided by 4 is equal to 1.5. And that's our answer. AC prime is equal to 1.5. Okay, and now the last one's kind of going the opposite way. So now we have AB prime. We have this little guy right here. And we want to know, okay, if this little guy is 2.7, what is the value of the large one, AB? And this is how you do it. We know our scale factor is 4. So we're going to take the small one, and we want to enlarge it this time. So we're going to multiply by our scale factor instead of divide. And we are going to get, let's see, 2.7 times 4 is 10.8 is our value for AB. Okay. So there's a specific set of steps here that you're going to want to have written down somewhere, because this is the format of almost all of these types of questions on tests and quizzes. So here are the steps. I'm going to write mine up here where I have some space. First, you have to prove similarity, okay? And that is, you want to use one of these three theorems to prove that they're similar. Once that's done, then you want to find your scale factor, okay? And the best way to do that I like to be consistent is you want to find a matching side, okay? So in this case, CB and CB prime is our match, and we want to divide the larger side by the smaller side, okay, for a matching side. Once you find the scale factor, oh, I ran out of space, so I'm going to have to put 3 over here. Step 3 then, it depends on what you have, okay? So our first one, we wanted to find the smaller length. So to get a small length, we're going to divide by the scale factor. So what we did here was we took the length that we knew and we divided it by the scale factor and got the smaller length. If you want to get a larger length, like the last one, then we are going to, so we have the small one, like here, 2.7. We want to enlarge it. We're going to multiply by the scale factor. Okay, and those are the basic steps for a problem like this. Now, we're going to do one more just to make sure, hammer home what we're doing, and then we will move on to the assignment. So on the next page, oops, I'm sorry, wrong page. Again, we are going to go to page 57 here. So on page 57, we have our next diagram. So it says in the diagram below, you have ABC and A prime, B prime, C prime. Use this information to answer your part. So again, like I said, the first question, based on the information, is triangle ABC similar to triangle A prime, B prime, C prime? So we look at our information, and remember, we have a choice. One, do we have 2 angles that are congruent? Do we have 3 sides in proportion? Or do we have a side angle and a side? So if I take a look at this, I have a match of 59 degrees and a match of 92. That's 2 angles. So yes, the answer to this is yes, these are similar because of the angle-angle congruence theorem. Boom. Now, once that's established, we can move on. So it says, given that these are similar, determine the length of side A prime, C prime. So that's this long length right here. We want to know how long is that length. And we're going to use our steps now. So the first thing we need to do is determine the scale factor from the lengths that we already have. So we have to find a match. And if I look at it, I have AB and I also have AB prime here. So that's corresponding sides that both have values. So we're going to use those to find scale factor. So I'm going to take the larger one, 5.12, and I'm going to divide that then by the smaller one, 3.2, and I get 1.6 as my scale factor. Okay, so once you find the scale factor, then we got to think about what we're trying to do. Are we trying to find a longer length or a shorter length, one from the larger triangle or the smaller one? And it looks like we're trying to find one on the larger triangle. So that means we need to multiply. So we're going to take our corresponding side of AC is 6.1, and we're going to multiply that by our scale factor of 1.6, and that should give us our new length. So 6.1 times 1.6 equals 9.76. That's what this side would be. Okay, and then again, we're to the last question here. So the last one is, given that these two triangles are similar, determine the length of side BC. So now we're looking to find this length, and that's on the smaller triangle. So since we have this length 8.96 and we're going to shrink it down, that means we're going to divide. So we're going to take our length that we know here, 8.96, and we're going to divide it by our scale factor of 1.6. And we get, let's find out, 8.96 divided by 1.6, and you get 5.6 right here. And you've answered all your questions. Okay, there is one more example in this module, or in this lesson, but for the sake of time, we're not going to go over that today. The homework that goes with this starts on page 59, where it says problem set, and they're all similar questions to the ones that we just did. And the problems go 1 through 5. So you're going to do page 59 to 61, numbers 1 through 5. If you have further questions, please come and see me either before school or at lunch, and I will gladly help you.